Chapter 12, Section 4, all about equilateral and isosceles triangles. So we're going to learn some rules based on whether or not you have an equilateral triangle, remember that's all the sides are the same, or an isosceles triangle, which means that two sides are the same. And here's our central question. Make sure you write it down. Make sure you answer it at the end. So here are our first two theorems for today. Pause, write them down. So our base angles theorem says that if we know that these two sides are congruent, and we know that because we've got the little red 1 mark and 1 mark, so those two sides are congruent, then the base angles, or the angles opposite, so opposite of the sides, are also congruent. So the angles, not the angle that the two sides make up, but the other two sides. I'm trying to think of all the different ways to say this. They call them the base angles. Not necessarily, they don't have to be at the bottom. You could have an isosceles triangle that looks like this, and it would be these two angles. Okay, because it's the angles that are opposite of the two sides. And then the converse of that is true as well. If you have two angles, such as B and C there, that are congruent, then you know that the opposite sides are congruent. So AB would be congruent to AC. Let me erase some of my scribbles there. Do that again. So if the two base angles are congruent, then the two sides are congruent. Okay? Again, it would be the same thing if you have some random triangle that's facing like this. Whoops. If these two angles are congruent, then the two sides are congruent. Okay? It would not be the side between the angles. Not that side, the other two sides. However, you need to visualize that, think of that works. Okay? So maybe you understand that it's the opposite, right? Or maybe you need to think about it in the negative, in that it's not the side that the angles between the angles. Okay? So let's see what all this means to us. It means we can say some things are congruent. Be very, very careful. The rest of this chapter, they like to put two triangles together. So we have this triangle and we have that triangle, and then we have the big triangle. Okay? So be careful. I like to draw the two triangles separately. So we really have HGK and HKJ. Okay? So I just took the left side there and put it there, and I took the right side there and put it there. I think it's a little bit easier to understand what's going on in our triangles. Okay? And then we also actually have the big one, HGJ. And that's the big one there. Okay? So, we're going to want to know if H is congruent to HG is congruent to HK. So, HG is congruent to HK. Okay, well, it looks like we then have an isosceles triangle going on here because we have two sides congruent. Okay, and it tells us that the sides are congruent, and so that means we know that then our angles are congruent, not the one in between the sides, but these two over here, G and K. So we can say that angle G is congruent to angle K. Similarly, down here we have if angle KHJ, so this angle right here, is congruent to KJH, okay, so that means that angle right there, because remember, it's the angle in the middle, the vertex would be the actual angle there, okay? So if these two angles are congruent, then the two sides that are congruent, not the one in between, but the other two sides would be congruent. And so we could write that then that's HK is congruent to KJ. And at this point, technically I should really have written JK, because the angles that are congruent should match up, so H and J should be in the same place. I'm not going to mark you off for that, though, at this point, okay? All right, so then we have some corollaries. Remember that a corollary is it just means that based on that other theorem that we already know, we can say that these things are also true, okay? So these are about equilateral and equal angular triangles, okay? It is saying that equal angular and equilateral are synonymous almost, okay? So if it's equilateral, then it's equal angular. If it's equal angular, then it's equilateral, okay? So if all the sides are the same, then all the angles are the same, and vice versa. If all the angles are the same, then all the sides are the same, okay? So what that means is that we know some things, right? And one of the most important things that you absolutely need to remember, and write this down, folks, is that if all of the angles are the same, it means that every one of them has to be 60 degrees, because remember, they all add up in a triangle to 180, right? So we have 60, 60, 60, that adds up to 180. So if your triangle is equilateral, it is therefore also equal angular, and all of your angles add up to all of your angles are 60 degrees, okay? So important, write that down. You'll see why when we start to do examples. So here is a triangle. Notice we have all of our sides congruent because they each have one, well, they each had one until I started drawing on them. Each have one congruent mark, meaning they're all congruent to each other. So this triangle is equilateral, right? Meaning all the sides are the same, which means that it is therefore also all equal angular. So we can figure out what all three angles add up to be, because we know they have to add up to 180, so they have to each be 60 degrees. That's that thing I just told you. So important. It sounds easy right now, but you forget it. Sometimes the easiest things are the things you forget the quickest, okay? So, again, we have an equilateral triangle. I know that because we have our congruent marks, one each side, one line on each side tells us that they're all congruent to each other, okay? And so that tells me that these angles are each 60 degrees. So we know that angle R is 2x, and we also know that angle R is 60, so we can say 2x equals 60, solve for x, and get that x equals 30, which is all that it asks for. Okay, so here we're told that the angles are all the same. We know that because they each have one congruent mark. Okay, so they're all equal to each other, so it's equal angular. Therefore, it is also equilateral, which means that all of our sides are the same. So if one is 5, they're all 5. So therefore, ST equals 5. I know you think this is easy. We're going to start to get a little bit more difficult, okay? Remember when I said when you have multiple triangles, because notice we have 1, 2, and then we've got the big one too, right? Draw them separately. It will help you, I promise. So we've got KLN here, and we know that's Y and that's 4, and they're all the angles are congruent, okay? And then, so that's that guy. And then let's draw this guy. So it looks kind of like that. And it says those two angles are congruent. Now, notice these two have two congruent marks, right? That's because it's saying they're congruent to each other, but they're not congruent to these over here. Okay, that's why there's different numbers of marks there. And that told us that that was x plus 1, and this is L in M. Okay, so now we can find the values of x and y. Okay, so if we go over here to this triangle, okay, we know that each angle is the same, so therefore every side is the same. So therefore, we know that if this side is 4, then this side is 4, so y equals 4. It wasn't too bad, right? And then over here, we can figure out what x is. We know that these two angles are congruent, therefore we know that these two sides are congruent. Therefore, I think I missed something. Oh yeah, so we know that this side must be 4 because all of the sides over here are 4, right? And that side is this side and this side, right? So we know that 4 equals x plus 1, subtract the 1, and x equals 3. So there are your answers. Notice all of this work. I expect to see all of that work on your assignment. And I have one more example of the same sort here. So again, let's draw this triangle here, 28, 2x, and then let's draw this triangle. I didn't do a very good job of drawing that triangle because I'm running out of room. Okay, there we go. And so that's all congruent, and that's 28, and that's 4y. Okay? Now, we need to, and this is this triangle, okay? We need to add some stuff. So, and this 2x is in this angle, by the way. So if this is 28, then this is 28, right? So this is 28, which means that this is also 28 because it's the same side there, right? Okay, it's important to notice. So if these two sides are congruent, then these two sides, angles are congruent, right? Okay, bear with me because this is gonna be kind of complicated, okay? So just follow with me. So, if this angle is 60, we know that, right? Because all these are the same, so they're all 60 degrees in there, yes? Okay? Oops, that's a Y. Then that means that together, these two angles are a linear pair. Remember when I warned you that that was going to come back all the time? Here you go. So these are a linear pair here, right? So what that means is that if this is 60 and this is a linear pair, they add up to 180, so this angle is 120. So this angle is 120. Okay? And you know that all three angles in a triangle add up to 180 also. So that means we can do 2x plus 2x, so these two angles, plus our 120 equals 180. Sorry, I'm running off into the figure there. So that means, let me change colors here. We've got 4x plus 120 equals 180. Subtract the 120 from both sides, and we've got that 4x equals 60. Divide by 4, and x equals 15. Okay, I know that was long and drawn out, but you have to be able to pull in all the stuff we've already learned in order to do these problems. That's going to be true the rest of this chapter and a lot of Math 2, which we start in January. Okay, so now we know what x is. Now we got to find y. Y is a whole lot easier. All our sides are the same since all of our angles are the same, so 4y, that's a 4. 4y equals 28, and y equals 7. Aren't you relieved that was so much easier? That's it. Sorry this ran long. Ask questions in chat.